you started it. I am going to record record this so that way I can post it and have it available just for reference. I apologize for getting the link out late. It completely slipped my mind that I hadn't created the meeting before I actually left. So last week we kind of got into an introduction and we started talking about creating our own creating programs and started working on the basic stuff. Worked in the chapter should have covered how material should have covered how to create a program that can accept input from a user and then basically go through, maybe do a little calculation on it and then output that information to the screen. So it's kind of, little things like I'm bring up idle like this. So if you sit there and we run this program, hit the right keys, and it comes just as simple things like that. So this week, the course is we're going to switch over, and for module 3, the chapter is going to start talking about decision structures. In this case, it's going to talk about Boolean logic, which is basically true. Boolean is a fancy word for working with true false. And basically what it's going to allow you to do is we're going to be able to write programs that go through and allow you to make choices as you go through. So say you, for example, if you look in the little header here, it shows a short program that says that asks the question, how many states are in the United States of America? And then it does this little statement that checks to see if the amount of states entered equals 50, then they were correct. And if not, it prints out, sorry, the answer is 50. So that's the type of things we're going to learn. We're going to learn about, we're going to learn how to use if else statements and to basically do logical branching within our code. But we're also going to learn about doing Boolean operations, because when you're sitting there, a Boolean operation doesn't necessarily need to be, like in this case, we're looking for equality. Boolean operations, you can check for greater than, less than. There's a bunch of different Boolean operators that allow you to use logic, basically put specific logic in your code to test for certain things. So I'm going to switch over to PowerPoint and bring that up, the fun thing that's so much fun to watch on Zoom things. So like I said, we're talking about this week's chapter talks about decision structures and Boolean logic. So like I said, the topics are talking about the if statement, which is just a simple statement. If this, do this, and then don't worry about anything else. The if else statement, which means if this condition, do something else, do something else. And then we're going to talk about with comparing strings, because sometimes when you compare strings, you expect one result and find out that because of how things are, how strings are compared, you don't get the same results that you would think you would get. We're going to talk about in looking at the decision structures, you can actually nest your decision structures. So if you look here, there's and we'll get into a little bit more, but there's the if, else. So that allows you to sit there and say, if this, okay, then if not that, if this, and if not that, if this, and if none of those, then this. So it kind of allows you to go through and check for different conditions before you finally get to your kind of default condition for way. And then the last things we're going to talk about is we're going to go through and we're going to talk about the different logical operators that you can use for Boolean discussions, and then working with Boolean variables. And then there's kind of a little example of turtle graphics determining the state of a turtle. Not too far there. So basically, what is the if statement? The if statement is a programming control structure. If statements exist in all programming language. It's kind of it's a base thing that's there. It's kind of a sequential structure. It's a set of statements that execute in the order they appear. So when you write an if statement, especially if you have a multiple if statement, if you have multiple levels in your if, statement, you have to understand that it executes sequentially. So you want to make sure that if you're looking for things and you have a priority, if you have a hierarchy in executing, and there's a possibility that what you're testing for may meet multiple conditions, that with that meeting the multiple conditions, you want the first condition, the higher priority condition, to meet first, because it's going to go through and execute in order. It's not going to go and look down at the bottom in different rounds. The if statement is a decision structure. It allows specific actions on, as it says, specific actions to be performed only if a specific condition exists. And that's kind of key for sometimes with programming, because when you're programming, you need to look and see, look at conditions and say, okay, maybe I need to go do this or do something else based off the conditions. Sometimes it's simple choices, sometimes it's more complex, and you may branch off and execute a completely different program based off your decision that's made. So if you're thinking in flow charting, if you've ever seen a flow chart, when you go through the things that we worked on last week, kind of, if you ever look at a flow chart kind of will have square boxes and triangles and, all different shapes in it. Well, if you look at the rectangle box is just kind of just your normal execution statements, which would be the things we did last week. In a flow chart, a diamond shape is more so the if statement, and because the diamond shape represents true false, so basically it's a yes no, kind of more of a binary condition. It's either one thing or the other. So example where we're sitting here and saying, what an ideal condition, because I'm sure I've heard it's been cooler there. However, I don't think you guys have hit 40s yet, and we've hit 40s the last 3 days where I'm at. So definitely, if it's cold outside, if you look at this statement, kind of, if you can see my mouse, if it's cold outside, if that condition is true, you wear a coat. If it's false, you don't do anything special. And this is just kind of the flow chart basic. This would be the if statement. And if that value was true, where you execute some kind of thing, action, which is wear a coat. So in Python, which is language we're working with, when you go through the syntax and in programming, there's a term called syntax. The syntax is kind of the order or ways that you format your words to be able to make them make sense to the programming language. So in this case, the syntax for the if is if some condition, then a colon. And then if you notice, we've got our indentation, then basically all these statements that are here that are on the same indentation under this if condition, those are all the things that are going to happen if this condition makes. So once we get back out of this indentation, we'll be back into executing things that aren't in that special condition. So obviously, as it says, the first line is known as the if clause. So it's your if statement. It's fairly straightforward. If this condition. So in the example here, if it's cold outside, that's true, wear a coat. So if cold outside, wear a coat is essentially it is. The key thing about this is it's always going to have this keyword of the if. If is a special word that you can't use. Like I can't name a variable if. Python will blow up big time. It won't let me name a variable if because it's a special reserved word. When the if statement executes, any of these statements that are underneath it, they only execute if this condition is true. So in talking about working with if statements, this second part, the condition. This condition is what's known as a Boolean expression. So your Boolean expression is an expression that when you put it together, the only result it can have is true or false. That's what a Boolean expression is. So example, A is greater than B. That's a Boolean expression, A greater than B. So that statement will return true if A is a value that's greater than B. So if A is 4 and B is 2, it's going to return true. If B is 4 and A is 2, then it's going to return false. And if A is 4 and B is 4, it's going to return false as well. Because when you're sitting there and you're looking at greater than, if they're equal, that's not greater than, so that's false. It's all, no matter what values you have in this statement, it's always, the Boolean expression is always going to return true or false. So in the middle of this Boolean expression is a relational operator. So when you sit there and you look, a good example of the relational operator is greater than. So the relational operator is the operator that's between the two values that you're using to compare the two values. Before I go forward. So examples of relational operators. You have greater than, you saw greater than. You can also have greater than and equal, less than and equal, less than and equal, greater than, less than. And when you sit there and you look, those are all the operators. So now when we're sitting there, we're looking to determine if the two operators are equal, you would sit there and you say, oh, well, let's look at, we can just use this equal sign. That should work, right? Because the equal sign is not a comparison operator. The equal sign is an assignment operator. So when I have a variable and I want to assign a value to it, I use just one equal sign. When I want to compare items, I have to use two equal signs, or equal. And it's just, this is common for a majority of programming languages. The only language where equal is both the comparison operator, only language I can think of off the top of my head that equal is a comparison operator and the assignment operator. And the language, the compiler kind of just interprets based on what's around it, is Visual Basic. Most of the other popular programming languages that are used, it's some form of equal that will go through and determine comparison. And then when you look here, you'll see that exclamation point equal, the exclamation point in this case indicates not. So in other words, you're saying not equal to. When you're working with Boolean operators in general, when you're working with Booleans, if you ever see an exclamation point in front of something that you know is going to be a Boolean value, that exclamation point is essentially the word, replace that in your head with the word not, and that'll kind of give you the idea. So in this case, not equal, to determine if the two are not equal. So again, looking at the Boolean expressions or relational operator, Boolean expressions using relational operators, obviously, X is greater than Y, X is less than Y, X is greater than or equal to Y, X is less than or equal to Y, X is equal to Y, and X is not equal to Y. So these are the core Boolean operators that you're going to be working with through the programs. So in this example, kind of a flow chart where you're sitting here going through, it's got the Boolean expression. It's got a Boolean expression using the greater than. So basically it's saying if there's some variable that's used higher up in the decision in the code that sets the value for sales. And here you're checking to see if sales is greater than 50,000. And if that's the case, if that evaluates to true, then there's some sort of bonus attached to it. So you set a bonus equal to 500. And if it's false, you do nothing. So that kind of just gives you the idea of how this falls into the decision structure. So kind of looking at the Boolean expression and relational operators. When you're looking at the decision block, any relational operator can be used in that decision block. So I can sit there and say, if balance is equal to 0, or if payment not equal to balance. And we can also sit there and say, if balance, so say, kind of using the examples above, if balance is greater than 0, then we can also do a second if that's underneath that and say, well, then if balance is greater than 0, if payment is not equal to balance, do something there. things like that. You can have nested, you can have if statements within if statements within if statements. And again, as you go through, the biggest thing that determines that determines and separates out the different if statements that are kind of going in on the inner blocks is your indentation. So you have to keep track of your indentation to make sure that things are indented and lined up when you're using cases like that. So kind of, we just talked about just the if statement. So there are other ways to go through, because the if statement only does something if your condition is true, if your Boolean expression evaluates to true. But maybe sometimes you have to worry about, I got to do one thing if this is true, but I have to do something else if this is false. So if that's the case, we can use an if else statement. And I always sit there, and because it was just in the initial languages I learned, it was if then else. And then kind of was assumed, even though it never shows in the code, but it's basically an if statement. So we're sitting there, we're saying, again, the syntax is if condition colon, whatever statements that fall under your if condition. And then when you're done with the things that do for the if, you say, you type the word else and another colon, and then you do another block of statements. One of the things syntactically is, if you notice, your if and your else have to be on that same indentation line. If they're not on that same indentation line, the Python compiler is not going to pick them up as being associated together, and you're going to have issues. And again, too, when you're sitting there and looking, your statements, the statements don't have to be on it, but again, you still got to make sure that you have your consistent indentation, your consistent indenting to be able to make the program flow. So when you're looking at the if else statement in a flowchart, so now you sit there and you see we've got our triangle, which indicates some sort of decisions being made. And you look now, instead of just having a branch off for true, we've also got a branch off for the false condition. So if temperature is less than 40, where I am, if temperature is less than 40, then true, display a little cold, isn't it? If the temperature is not less than 40, display nice weather we're having. So this shows you, here's the condition, and this shows you the if part is over here, and then this would be your else part. And again, this is kind of just showing, demonstrating the different blocks of code, So not on PowerPoint, let's work. So now when we're sitting and we're working, kind of all the examples kind of use some variable and typically worked with a number for the most part. You can also do comparisons of strings. So strings are, characters. The obvious way you can sit there and look at strings is look at equal or not equal. So we can sit there, if name equals Tim, print hello professor. If not, else print hello student. Things like that. It's real easy to compare strings for equality. And you can see the equality very clearly with strings, or the inequality. One of the things with string comparisons is string comparisons are case sensitive. So if you type in a word that has, if your two words are exactly the same, but one is written in all uppercase or the other is written in all lowercase, the comparison is going to return that they're not equal, because it is case sensitive. But you can also sit there and, you wouldn't think that you could look at characters and do greater than, less than, greater than or equal to, and less than or equal to. But basically what happens is, when I use the greater than, less than, and all those, what the compiler does is it goes down character by character, and it looks at the ASCII value for each character. And what ASCII is ASCII is it's a way to sit there and convert your common characters in, common characters that you would see. It converts them to a numeric value. There's also some special characters and unprintable characters that fall into that. But for the most part, it's comparing, it's basically going through character by character in your string and looking at them based off the ASCII value. And that's actually what happens when you're using these values too as well. And that's what makes it case sensitive, because an uppercase A has a different ASCII value than a lowercase a. So another thing looking at it is, say you have, in case using my name, where you're sitting, you're looking, you're comparing, is Tim greater than Timothy? When you sit there and you look at it, since the first three letters match, it's going to look at the fourth letter. And since the first word doesn't have a fourth letter and the second word does, it's going to say that second word is greater, because it's just based off, even if what's available of the shorter word matches the first part of the longer word, it's going to say the longer word is greater because it's longer. It's got more characters to it than the other. So when you're sitting there and you're looking, this kind of sits there and kind of gives you an idea. The 77, 97, 114, 121, and 107 are the ASCII values for each of those characters. So as you see, one of the things to note is uppercase ASCII values have a lower, uppercase letters have a lower ASCII value than lowercase values. So when you're sitting here and you're doing comparisons, you would think, logically, you may think uppercase is greater than lowercase, but that's not the case when you're looking at ASCII. So in this case, comparing Mary to Mark, Python, if you did a greater than or less than, Python would say Mary is greater than Mark. Why? Because when you come to this fourth character, the ASCII value for Y is greater than the ASCII value for K. And that kind of makes sense, because when you sit there and you think logically, Y is further along in the alphabet than K is. Y is the 25th letter of the alphabet, whereas K is, lower down. So, and kind of real quick, let me see. I didn't want to close that. I want a separate window. Thank you. So there we go. So just to kind of give you an idea, and this is kind of, you don't need to know it. You can do exactly what I did, where if you sit there and you look up ASCII values, and I'm gonna, yay, let me zoom. I just gotta remember that I gotta zoom back out when I go, if I go to the browser. So when you look at it, this is your ASCII chart. So when you sit there and you look, you see decimal value, hex value, and occ value, and it's got the character. Some of them have character. And then as we sit there and we get out of that first column, we kind of move over and you see we have a HTML. If you're programming in HTML, you would need to know these, otherwise you don't. But as you see some sort of like this first character, the first column is kind of all of our special character, like special non-printable characters. So for example, things that I learned in programming is the ASCII character 11 is always tab, 10 and 10 is backspace. ASCII characters of 12 and 14, and there's just different characters. So when you're sitting, you're looking, carriage return line feed is the same as hit the 12 and 14 is the same characters that you would get if you hit enter in your program. Then as you sit there and you start looking in these last three columns, you start seeing the ASCII value. So a space is the lowest of the printable characters in the ASCII value table. So as you see, a space is 32, exclamation point 33, quote, as you go down the list till you get to the numbers, 0 is 30. So any number as a character is less than a letter as a character, as you can see in here, then you start getting into some of your symbols, some of the symbols, some of the grammatic symbols. And then you get into your alphabet, and as you see, we've got our uppercase starting at 65. You've got your uppercase letters, and then you've got some more special characters. And then you get to 97, you've got your lowercase characters, and then you've got some more special characters. So kind of to give you an idea of what the ASCII values are, when you're comparing strings, it goes through and finds each character in your string and converts it to these numbers. And I actually do it more on the hex level, but you can look at the decimal base number as well, base 10 number of it. So the last kind of decision structure that we're going to talk about is if you have multi-levels of decisions, or if you have multiple ifs that you have to check for. So if you're checking, if you meet this, if it's not this first condition, then is it the second condition? If it's not the second condition, is it the third? Otherwise, don't do this. So when you're sitting there and you're looking, you can have this is commonly called a nested decision structure. Or no, sorry, not nested. This isn't, I don't know why it's talking about nested in here with using the if elif, but basically what's going on in here is it's talking about if someone qualifies for learn, they have to meet two conditions. So therefore you would be doing an if statement to see if they made at least 30,000 a year. And within that, you would do a second if statement that says if they've been employed for at least 2 years. So you'd be checking for the first condition, and then if that's true, check for the second condition. So again, I need to look through because this doesn't make sense with the logic for it, but kind of going through, here's the flow chart for that condition it talked about. If salary is greater than or equal to 30,000, then if years on the job is greater than or equal to 2, they qualify for the loan. And then basically off the false, if they make less than $30,000 a year, hey, you need to make 30,000 a year to qualify for the loan. And you have to be employed at the same job for 2 years to qualify for it. So when we're working with nested structures like this, you need to make sure that you pay attention to your indentation, because the indentation is going to make sure that it goes down the right path. Okay, it just started the header of the L. So so note when we're sitting there talking about the nested decision structures, and the LF nested decision structures are if this, then if this, else. Whereas you have another decision structure called the if elif else. So this says if this basically allows you to have multiple if statements that you can go through and check for things. So with the multiple ifs, it's saying if any one of these conditions is met, do these things. So you come through, you check for condition 1. If condition 1 is met, you do the statements associated, you do the things associated with condition 1. Otherwise, if condition 2 is met, you do the things with condition 2. Otherwise, if condition 3 is met, you do the things with condition 3. And if all else fails, you do these statements. So this allows you to sit there, and again, when you're sitting there looking, your alignment lines up, your ifs and your elifs and your elf all have to be on the same, else have to be on the same line. And when you're sitting here, you're looking, you can go through and you don't need to do, like, if you program right, you don't need to do the if else. You can easily accomplish the same thing with the if else statements going down the line. However, sometimes the if else statements being nested, it becomes very complex. It becomes very hard to read. And it makes it to where, it makes it just because of the indentation and stuff, it introduces the chance of making mistakes more. So if you have multiple conditions that can be met for certain things, you might want to use this if, elif, else logic. So here's our flowchart example, and this is perfect, perfect kind of example. If the score is greater than or equal to 90, your grade is an A. Else, if the score is greater than or equal, your grade is B. If your score is greater than or equal to 70, your grade is a C. If your score is greater than or equal to 60, your score is a D. Else, your grade is an F. Is that kind of making sense? This is where you sit there and you look, the if, elif kind of waterfalls down in the decisions, whereas, and I'm going to come back up here, the nested if, it kind of, as you see, it's not, it comes, it true, or, it's got a little bit of a different look to it. You see coming off here, the false statement leads, like, so basically when we're sitting here off, when we're doing nested, a lot of times you'll have, true another condition, true another condition, or false condition, false another condition. We're here using the elif, true, we go right to statements, and false, we go to another condition until we get to the very end. So it's a little bit different of a structure if you're looking at the flow chart. So now that we've kind of talked about all these different structures, we're going to talk about logical operators. So your logical operators, the two main ones that work with it are and or. What they allow you to do is be able to create a more complex Boolean condition. So I'm going to kind of come back up here to our condition here. This, you can do it with a nested if statement, or since these are two things that you must have to qualify the loan, you can say must earn at least $30,000 a year and must be employed for at least 2 years. And I'm sure to probably have a different example. You also have a logical operator that we've kind of talked about a little bit with the not equals, is you have the not operator. So basically what the not operator is, it's what they call a unary operator, and it reverses the truth of its Boolean operand. So when you think about it, if you say something is not true, logically, in my mind, not true is false. And when something is not false, well, then if it's not false, it must be true. That's what the not operator does. So when you're looking at things and you're looking at it, we're going to kind of look at the and operator first. So the and operator, the way it works is it creates a compound Boolean expression. And the biggest thing you have to understand is looking at the truth table. So when I have two things that are false and I put them together with an and, false and false is always false. When I have false and true, because I'm using and, as long as there's one version of false, one version is false, whether it's the first part or the second part, with and, it's going to return false, because everything must evaluate for the expression to be true. When you're using and operators, everything must evaluate to true for it to be true. If one thing in your and statement comes out to false, your entire and statement becomes false. So as you sit there and you see the truth table, false and false is always false. False and true is false. True and false is false. Only true and true is true. We're working with the and operator. Does that make sense? Switching to the or operator, and just, I don't know if they meant to have it be like that, because that would make more sense if they had an or there. But the truth table for the or table, or, is when you're sitting here and you're looking, when you have false or false, always resorts to false because you're false on both sides. If I have false or true, then the statement evaluates to true, because for your or operator in your or statement, only one expression has to be true for the entire or expression to be true. So false or true evaluates to true, true or false evaluates to true, and definitely true or true evaluates to true. So the easiest way to determine when you're programming whether to use and or whether to use or is if you have your if statement, if your if statement is a case like we talked about earlier with the loan qualification, if you have to make $30,000 a year and been at the job for more than 2 years, then you would use and. If it's one of those conditions, if you know, if you only need to make one of those conditions, then you would use or for it. And is basically the operator that you want to use joining Boolean expressions when everything has to be true. So again, this is kind of going through talking about the or and and operators. For an or operator, if the left operand is true. So when we're looking at the or operator, if the first thing you look at in that or statement is true, you don't have to look at anything else because you know that or statement is going to evaluate as true. If that first thing evaluates as false, then you need to look at the second thing to see if it's true, because that's the only way it's going to become true. For the and, if the first thing I see is false, then I know right away my and statement is going to evaluate the false. I don't have to look at it anymore. If I see the first thing is true, then I have to look at the second thing to see if that's also true for it to evaluate as true. And if that evaluates as false, that your statement is false. The not operator. So the not takes your Boolean expression, your true or false expression, and reverses it. Sometimes when you sit there and you see it written in programming, you'll see the not operator and then parentheses around what it's saying not. And it's just basically, it's just kind of isolating what you're saying, kind of gives a little bit more clarity as to what you're saying is not. So looking at the truth table for the not operator, if I use not on a true statement, not true is false, not false is true. Again, it's kind of, all this stuff should be logical because we're working with logic expressions. So kind of now going through how do we apply it. So when we're sitting here and we're looking, one of the things you can do is you can check numeric ranges. So if you want to look to see if a specific value is within a specific value is between two numbers. If you're looking to see if it's in a specific range and you're using the and because you want to sit there and see if it's between two numbers. Well, I can sit there and say if X is greater than or equal to 10 and X is less than or equal to 20, that statement tells me that my number, if that evaluates to true, then my number is between 10 and 20. So if I want to look for everything that is not, if I want to look for everything that's not this, one way I can do it is say, if X is less than 10 or X is greater than 20, that puts it outside of the range. So you kind of see the logic here on it. Using the, if you're looking for a specific value within a range, within a range, specific range, you can use the and operator. If you're looking for values that are outside of that range, you can use the or operator, and that will give you the results for it. So when we're talking, going through talking about Boolean variables, the Boolean variable can only, Boolean variable or the bool data type can only have two values, true or false. In the eye of the programmer, in the eye of the program, in the eye of the computer, this is your most basic operator. It's kind of the easiest way to think about it is a light switch. A light, assuming no dimmer, a light is either you go up to a light switch, you turn it on, that's true. You turn it off, it's false. It's kind of sometimes you'll see one of the ways you'll see Booleans represented or referenced to as flags. So you can basically, a flag is just a variable that I set to the value of some condition. So if I go through and I do a calculation to see if you're eligible for something, and I take the Boolean expression that determines if you're eligible and put it into a variable that I called is eligible. Now I know when I look at that variable of is eligible, that they've met the condition of being eligible, or not eligible by it being false or true. And just again, to reference it, if Zoom didn't put up I know I've seen other meetings, I don't know if it does it with the school stuff, but if it didn't put up the thing, I'm recording as well. So this will be available. Once it's available to me, I will go through and do what I need to do to it real quick and then post it for you guys to make it available to you as well as a recording. Because I saw in the chat, somebody's having connection issues. So the last thing is when we're sitting there and we're looking, it's kind of a example of a thing going through and saying, hey, we're looking at determining the state of the turtle. So in here, we're assuming that if we call turtle.xcore, and this is some function that's associated with the turtle that basically gives us the turtle's x coordinates and the turtle's y coordinates. And when you're looking at this, it kind of goes through and it's going to give us a value. So one way we can use this is to sit there and say, hey, if the turtle's y coordinate is less than 0, that means it's gone, off our grid, say. Then we're going to reset and we're going to call this function go to 0, 0. So basically what's going to happen is we're going to move our turtle back to 0 if we go below 0. And here we're looking at a specific range. And for some reason, if the turtle's x coordinate value goes within this range, goes between 1 and 200, not inclusive, if it goes in there, that we're also going to reset it. And this is kind of an example of this is your Python code. This is a little bit more advanced of Python code, but it's still sitting there and saying, if this value is less than this value, do these statements, which is just this one statement. If this value is greater than this value and this value is less than this value, do this statement. So that's kind of giving you an example of the if statement. And again, looking at it, we may see more advanced things in this turtle.heading, using this turtle.heading and, stuff, but you still look, we say, hey, if the value of heading is greater than or equal to 90, and the value of heading is less than or equal to 270, again, we're checking if it's between this range, we need to reset the heading to this. So again, it's going through using our Boolean operators to set the state of this turtle. So here we're kind of looking, and this is a little bit different because we're sitting there and we're looking, is down is something that is a Boolean, it's a Boolean variable. So it's declared as Booleable. So is down is going to return true or false. So basically we're saying, hey, if it's down, return the value of pen up if the turtle is down. If not, turtle is down. So again, we're using the not expression here to see if the value of, like, basically we're looking to say is down means that it's down. So we want to determine if it's not down. Well, if we use the not, we say if not down is true. If not is down is true, that means pen, set turtle pen down. It's kind of that you're looking when you read your expression, especially when you read expressions like this, again, you're reading it as this. You can easily say if turtle is down equal true. That's essentially the same thing. And this is saying if turtle is down not equal true. That's what these two statements are. It's just kind of shortened. And then obviously we're sitting there again, we're calling just calling another thing that returns, we're checking for something that if is visible, we're saying if visible is true, then we're kind of hiding the turtle, which is setting visible to false. You know, it's just going through doing logic. Again, here we're looking at strings. If turtle pen color is red, then we're changing the pen color to blue. If turtle fill color equals blue, we're changing it to white. So as you can see, it's still logical statements. Again, looking, if turtle background color equals white, we're going to change it to gray. If turtle pen size is less than 3, we're going to reset it to 3. So that way you can't go too small. And if the speed is 0, it's moving too fast. So we need to set it back to 0. So, and again, this is an example from the textbook that kind of goes through in running the turtle graphics program. So I know it's kind of, I've been going through, holy cow. I went through that in, sorry, I was checking a message that came in. Looking at the chapter, it's basically, we're talking about we talked about decision structures, and we talked about working with them to where we're sitting there and kind of working on our decision structures. We talked about the single alternative decision structures. So basically the single alternative decision structures is our if statement. If this, then just do these. Your dual alternative decision structures are your if else statements. Your nested decision structures could be either the nested, like where you have if, or using the if, elif, else. We talked about our relational operators. We talked about greater than, less than, greater than or equal to, less than or equal to, not equal to, and our logical operators, and, or, and not, and how you can combine those all together to be able to create Boolean expressions. We also talked about string comparisons, how string comparisons work, that string comparisons sit there and it goes character by character. And basically when you're doing a string comparison, it goes character by character, looking at the ASCII value, and it looks and finds to where it goes character by character from left to right, looking at the ASCII value of each character. And when it finds a different, it compares the two ASCII values, in which, if you're testing for greater, it returns whatever's greater. If you're testing for less than, it returns whichever one was less than. You know, it based off that. We talked about Boolean variables, or like what we can call flags. So when you look at Boolean variables are variables that you set to some Boolean that you set using some Boolean expression. You could simply set a Boolean variable by saying, you know, is true equal true, and that's setting it to true. Or you can say is true equals some elaborate expression. And then it kind of talked a lot regarding this determining the state of the turtle and this turtle graphics that the chapter talks about. The turtle program stuff, and somebody mentioned in the chat, the reason the turtle graphics stuff is important is it talks about it in a chapter, and it uses it as an example, and it also provides example code with it. And that's kind of why it talked to it in the PowerPoint. So let me close this out, and then I'm going to switch over here. So kind of jumping back into Python, looking as a review. So last week I kind of going through last week, we did things like this. We went through and we took some sort of input, said, what is your name? Wrong order. I'm typing so well. And I never did find out why the F function is not working in the classroom, but working elsewhere.
It was just a different version of Python. I think at that time it was format instead
Yeah.
of F. Yeah.
Yeah, I don't know. I'll have to double check that when I go in there. So if I go through and I run this program and on my laptop, I gotta remember to hit the function key to get to F5. What is your name? Hey, it didn't lie. Sorry, my room just got really warm. So it must have dropped enough in temperature that it switched from AC to heat in here. So as you see, that program asks me what my name is. And by the way, as going through on the inputs, if you notice, if I don't put a space after my statement, it makes the formatting kind of look a little bit weird. You know, simple stuff like this is kind of what we covered last week. So now, since I've got this simple program that I've gone through, I'm going to go through and I've got where, again, I'm going to use this part here to get name and age. And then I'm going to do some logical statements with it. So if age greater than or equal to 50, oops. I tried to do a Visual Studio thing there and I'm not in Visual Studio. So I want to come up here. I want to print hello, you are that. If age is greater than or equal to 50. So we're going to simply, I'm not going to go to that part yet. We'll just stay there. Clean up just to make things look a little bit, there we go. So I went through and obviously we have the calculation, I get the age, I go through and look at your age, and now I do a simple Boolean expression to sit there and say, hey, if you're eligible, if you're over 50, you're eligible for AARP, because yes, I am 50 and I just hit that and I got lots of mail from them all of a sudden. So save it. So obviously it showed that. And then if I think I can get away with this. Nope. I forget how to restart my program. So we'll just come back here, do this again. Oops. So notice that when I put in 1972, it determined my age was 49 now, and it did not output the line about AARP because that was conditional based on me being greater than or equal to 50. So that's an example of how the if statement is. So then if we add a little bit more code here, we type in else. So, oops. Anybody know what I forgot?
The age or oh, the colon.
For all lines like that, for the if, else, elif, you got to put a colon after them.
Okay.
Control S to save, run. What is your name? him, what year were you born? 1971. I'm eligible for EARP. Yay. I keep on wanting it, for some reason, I keep on wanting to hit tab. That shows the else statement working. When you sit there and you look. So let's make this a little bit more complex, like the example in the notes. And we'll still keep it as an int. So kind of just a side note to point out something with it is if you notice with my variable names, I kind of have a habit of salary is one word, so it's all the same case. But now I have years working and it's two different words. I lowercase the first and uppercase the next one. And if I had a third one or fourth one, you would see I would uppercase each word. That's just a programming technique or a style. It's a style thing. It's not specific to any programming language. It's just something that programmers will do for different in typing different variables as different case. It's called camel case. And basically what it allows you to do is kind of differentiate different types of variables. Like I believe constants, in certain languages, they do all capital letters for constants. So if you see something that's in all caps, it's a constant. You see something in more of a camel case, it's just a variable. If you see something, just different formats. Some programming languages will use, you can use underscores. It's more of a style thing than a requirement for the programming part of it. Okay, so kind of typing that out. This was the one example where it look, do you qualify for the loan? Qualify for loan. Save. So it runs through, what's your current salary? How long have you been at your current job? And I'm purposely going to put 1. So now you sit there and you see that it went through and it did the logic, and coming through, it looked, it said, okay, I met this first condition. And then it came and looked, I did not meet this second condition, so it went to this else. And obviously now it went through, met the first condition, met the second condition here.
Is that nested?
No, that's not it. I know there's a way to.
Out of curiosity, could you move that final else up underneath the first if to kind of make it a little more
And see,
organized?
now we sit there and we look. Now, one of the things we could do is you could sit there and real quick, jump out of, not, well, no, so it's going through and like, that's what I wanted to say is something for with the if conditions is we're sitting there and saying, if you wanted to be more friendly of a programmer, move the input for years working to, only if you qualify salary wise. And running it. So now when I type in 25,000, it automatically kicks me out because it doesn't care. It doesn't matter how long I've been working because I didn't meet the first criteria. It only worries about it if I meet the first criteria. It's just different, different ways of doing it. So this is, so kind of going through, this is the example of the nested statement. This is when you sit there and looking at the code, you can kind of see the nested nature of it. We have an if nested under a net if, kind of going through. If for some reason there, if you're working at the job, I don't know. I can't think of another situation you would have. So we're gonna show something. And that bothered me not being spelled right. That to the right. Something to make sense with not owning a home and not being eligible for the job. Save. So 31, 5. So now, and I'm purposely going to do something. So now I've typed in an answer to the question. That's a legitimate answer to that question. So looking at the logic for looking at my logic, well, wait a minute, it met the condition of if am I a homeowner? So kind of when sitting there for right now, looking at this, obviously I can sit there and I'm looking, do I own a home? So there's several things that we can do. Based off what we've learned so far, there's one thing we can do is where we sit there and we look and we say, okay, do you own a home? Kind of So now we can tell the user just to enter in Y or N for yes or no. And then here we can say this or no, that's not what I want. That's what I want. So now we're sitting there, we're saying, when we come through, what is your current salary? We meet the salary. Oh, we did not meet the salary requirements because I forgot to, I didn't put enough zeros in. So now I'm sitting there and it's saying enter in Y for yes and for no. So I'm going to enter in the uppercase Y and it works. Because now I'm using my or condition to sit there and say if it's an uppercase Y or a lowercase y, then it meets the condition. And again, this is, as you see, the nesting kind of goes down and then you see, because in this case, we have else conditions for all of them, you kind of see, if you look at the shape of the code, it kind of starts to form an arrow. So the next example, it had kind of working, instead of doing a nested if, we're going to switch our program up. Oh, not defined. Int. So with the way I'm doing this is I'm going through and I'm making sure that I get a grade, and that grade is an integer number. So I'm looking, you know, maybe give something to prompt the user so they know. So Felix said, so the equal are case sensitive. So all string comparison is case sensitive, because remember how I told you how string comparison works. String comparison converts the string to an ASCII number, to each going in order, it converts each character to its ASCII value. So when you sit there and you look, lowercase are greater than uppercase in ASCII form. So when you're sitting there and you're looking at case does matter. And when you're sitting there and you're looking and you sit there and you see where if something is an uppercase and something is a lowercase, it's going to say the uppercase is less than the lowercase based off the ASCII value. But that's why I said, if you look up ASCII values, you'll get an idea of how string comparisons work. But yes, all string comparison is case sensitive. So grade is, we're getting the grade, we've got it as converting it to an int. If grade greater than or equal to 90. L if grade greater than equal to 80. So I want to point out something, especially with working with idle. I forgot to put my colon, and so without the colon, see where I go, where it took the cursor to? With the colon. So a good clue that you may have forgotten a colon is if your cursor goes back and doesn't automatically indent in idle, odds are you probably forgot a colon or something that you need if you're expecting an indent and it doesn't. So looking at it now, this is a, not a nested if, this is using the elif. So one of the things, obviously the biggest difference is looking at it, when you saw the nested if, it kind of went and formed kind of a arrowhead shape, or at least kind of started, things kind of went, as you saw looking at the indent on the next nested if, you see things kind of start shifting this way, where with the elif, everything's in line. So control save, run, no errors. What was grade 95? And there's the output. And you see it went through. So as you see, kind of looking through the code, we've got here, it's going straight down. Again, it's executing an order. It's looking at what value grade has, and it's looking, did it meet this condition? No. 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 Then go here. And if it meets any of these conditions, it's going to go right here and then skip the rest of this. So that's one of the things too to understand when we're working with the conditional branching and the conditional logic, when you're working with if statements, is once, as you're going through and doing ifs, whether they're as in this fashion, as you meet a condition, you will hit and execute the statements for that condition, and then you step completely out of the process. So if you're looking and for some reason you had to have test if it met this condition, then if it met this condition, check for this condition. You want to use, like, basically the difference between using the if elif versus the nested if is if there's multiple values for the condition that you're looking for. So in this case, grade, if the grade is 90, then this, if it's 80, then this, then it's 70, then this, then it's 60, then this, otherwise it's this, then you're typically going to want an if elif. If it's something where it's conditional, where it's got to be this condition, this condition, this condition, then this condition, then this condition, you'll want to use the nested if. Or you could use your and or operators as well for that to avoid the nested if, but sometimes the nested if makes more sense. So this is kind of a example program doing that. So then we'll come through. And something. Something that drove me crazy on my way up here. So one thing that we could go through is we've got basically this program is going through, and again, because in the way I type things out, because I've got them on all caps, these are just kind of constant values. We're not going to change them. I haven't declared them any special as a constant other than doing that, just so that I know for right now. So I say if current speed greater than 70 or greater than Boy, I am typing real well. So I want to point out something that I kind of started, that I just noticed that I was doing because my brain switched into a little bit more of C sharp. By putting the parentheses around my statement like that, that's not going to break anything in Python. It's not required. But what it does is now, since I have this compound statement using my and, it allows it to sit there and kind of show that this is what the whole, this is everything grouped together. Just the parentheses mean kind of equal grouping. It shouldn't cause a problem. And so I kind of purposely did this as an example, and we shouldn't have compiler errors with it. Control C. If it works. So what is your current speed? So 75. You belong in the left lane. And obviously you sit there and you see, the point I wanted to bring out is I have if, elif, but there's no else. I'm not required to put an else. If in going through and testing my three conditions, I cover everything I need to cover, well then why have an else? I mean, I could have easily accomplished this with else, but maybe at some point I want to change this condition, and have add something else. This is just a different way of expressing it. But when I run this again, you see it's going through processing it. But if you look here, I'm using the and statement to check for an range. So I'm looking to see if my speed is between the minimum speed and the maximum speed. Trying to think of a condition, trying to think of an example where we could use an or statement to be able to check for outside of a range. So going here, I got a condition. That would be within the range. I'm trying to think. Just trying to think of an example for with an or for with. Trying to think of a good example for using the or for kind of like an include for checking to see if you're outside of a range.
Is it possible to program conditional statements as truth tables?
I know one. Int. if age is so this kind of goes through and this shows an example of using the or to change for something that's outside of a range. So the range is ages between 13 and 19. So instead of checking if I'm between that, I'm checking if I'm outside of that. And outside of that would be less than 13 or greater than 19. In this case, when we run this program, save it. What is your age? 15 is definitely a teenager. Oh. Fat figured and entered it, fat figured and hit a period. And it shows that I'm not a teenager. So I believe I've covered all the different things that will be covered in the chapter. So does anybody have any questions? You can either open up your mic or pop into the chat.
Seems pretty self-explanatory.
Questions? Anybody have any? So if that's it,
Hold
then
on.
if we kind of covered everything, this would be the point in class. Like I said, my goal with the class is kind of like we go through and it's a little bit harder in Zoom to do these last things, these things I was doing as an interactive as a we do type thing. But in class at this point, I would sit there and say, okay, we're ready to sit there and move over to the parts where you're working on your assignments. So therefore I would open it up as lab time and give you time to work in class on lab stuff. Starting on your assignments with me available to help you, or at this point, I would say, if you want to work on it, you're at home, go ahead, you're free to go. But since we can't really do a lab on Zoom, if you guys don't have any questions, or comments or anything like that, we're done for the day. I am going to go back to here real quick. So if you sit there and you look at the course, we've got all the example programs from the chapter are here listed. There's a YouTube video that kind of talks about relational operators, that talks about the materials. The PowerPoint I went through, there's some activities that if you sit there and you look, the operators activity, one of the things I wanted to point out with this, clicking through this operators activity, is it's kind of got a little bit of things in it to where you can sit there and going through and saying, okay, like this, match the operators with their meaning. So this is match this with that, match this with that, match this with that, this with that, this with that. Kind of something to go through and, test your understanding of things. Or you come here and detect a teenager. Now, one of the things I wanted to point out in here is this kind of shows you an example of what pseudocode is. As I was talking about it last week, pseudocode is following your logic written in plain thing. So it's ask user to enter age in an integer. If age is within parameters for a team, put out that as a teenager. If not, report the user is not a teenager. And then basically what you're going to do is you can doing this part, you can reorder your code, reorder this code to be able to get it to work in the proper order as an idle program. And then if you want to, you can copy this code out of here into idle and go through and play with it some.
So I am kind of curious, and I think it may
Assignments,
be best-
there's a quiz like always. There's the preparation program, which the preparation program is going through writing a program that does this. And again, we want to use the format or the F string on the different things. And then once you submit that, your assignment is 3 programs that are going to do each of these. And then as you see, if you see, you look at the programs that they're there, it's kind of going through, you're doing a lot of different things for output. So you're looking to say, going through and saying, hey, how much based on loyalty points, how much, calculate, do some calculation to figure out what the discount is for the loyalty points that we get. Here's a program, even multiples of 13 that is more than 150. So basically where you can sit there, it's going through to figure out even multiples of 13 that are more than 150. You would be using the modulus operator, and you'd be using basically division and modulus operators for integers to be able to figure out if it's even, and then you would be using logical operators to figure out if it's more than 150. And then you can go through and do, based on base the output on it. And then your third program is kind of a quiz where you sit there and you're going to ask 3 questions. The first question is going to be something that the answer is going to be, a quiz question is going to be return an int. The second one's going to be a quiz where the answer should be a float. And then the third should be a string answer. And you're going to be checking if I'm giving the right answer. So like the first one, it could be how many days in a week. And if I type in anything other than 7, I should get that I got it wrong. The second one could be, what is the value of pi? And if I type in anything other than 3.14, you can go through and, say it's wrong. And then the third, require a string answer. What's the capital of Florida? And if I type in anything other than Tallahassee or, something like that, you can check, do things like that. So is that making sense with the different assignments?
Yeah, I just have some specific questions in regards to the first assignment and
So
submission
does anybody
deadline.
have any questions, comments,
Can you hear me?
alibis?
I don't think you can.
That I've got to look through. Since I pretty much left right after class last week, I still have the old version of the book with me.
Hey, Felix, can you hear me?
And I'm not hearing anyone, so I'm wondering if my speaker just shut off.
Hey,
I
Professor
think his
Schultz, can you hear me?
His speaker shut off, I'm pretty sure.
Ah, okay. Yeah, we've been talking to him pretty much the entire class, right?
Yeah, I could hear you. I could hear
Okay.
Josh as well.
Okay, awesome.
I just don't think he can hear us.
Okay, now I'm hearing again.
Okay.
I just needed to maybe reconvene with you offline in regards to the submissions and some instructions for the first assignments. Just need to get
Okay.
some clarification on that. But yeah, other than that, for me, it's pretty straightforward.
All right, just shoot me an email through my courses and we can work it through there. And if we need to meet in a separate meeting, we can, but probably can take care of it via email as well.
Yeah, definitely.
Okay.
Okay, also, I had a question. As far as like digital inputs, such as if you're using a Arduino or something along those lines, if this and all these commands, they would actually make a big difference as far as digital inputs. Are we touching on that later in the class? Or is that
So
further
as we go through, we're definitely going to definitely build on it. As far as for like looking at this last part right here, this last question here. So as you saw when I was doing, and here's a perfect example, to make sure that my input is an integer, I go through and I put an int. If I wanted to make sure this was a float, I put float. And that's going to sit there. And right now, if I go through and run my module, save it, and I type in, it's going to give an error. And that's exactly what's expected. Because you entered something in, we haven't covered error handling, so that's exactly how it should be. If we put bad input in. And then if I go through and it should take it perfectly in, because now I can enter periods in, because that is a float. And then if I change it back to int, save, run, and put 10.0 now in, now it's going to sit there and it's going to tell me, hey, it's that's not a valid input for int. But we will further along in the course kind of cover handling stuff like that.
Okay, so we will get into like the different ports and inputs and everything like that.
Yeah, I mean, as much as we can. I mean, it is it is only an 8-week class, and it's while it crams a lot in, we will cover a lot of the things. We will cover, like, when we get to that point, we'll be able to sit there and be able to I think we cover I'm trying to remember, I think we cover converting, like for example, with working with strings. So say you're looking for string and you want to make sure that if the user, no matter what case the user enters it in, you're comparing the same case to make sure that it's correct. For strings, I know there's functions to be able to convert strings to all uppercase or all lowercase and things like that. And there's things to do where you can do error handling and conversion other than just forcing your input into being an int, and we do cover some of that.
Okay. Well, thank you for the examples. It really helps.
Okay. And again, like I said, I recorded this, and once I get done and the recording is available to me, I will go through and do what I need to do to be able to post it out. I actually have kind of like a small YouTube channel that I use to post, just mainly because YouTube inserts the captioning stuff that we're supposed to have for the college. And I'll post it out there and then post a link to it within the course, so that way you guys have it for review. So if there aren't any more questions, have a great, today's Wednesday. Wow, I'm like, being off for a week is really throwing me off. Have a great rest of the week and enjoy your weekend.
Thank you, Professor. You have a good day.
Yep. All right.
Too.
See you, everybody.